Hello, everyone. Welcome back from the coffee and networking break. Hope you guys had time to recoup and get ready for the next block of talks. Right now, we have a topic transforming trading with AI and ML, real deal versus myths. And for this talk, we have Vladimir Lucic from Imperial College London. Vladimir, how are you doing?
Very well. How are you guys? Hope the coffee break was good one.
Yeah, well, we have, as I said, a tight schedule packed
Yeah,
and a lot of content to go through. So I wouldn't really take up any more of your time.
yeah.
You're free to start.
Thanks. So as you can see, the title is slightly different from what was advertised in the schedule. So as it says here, it's a person's perspective about quant finance over the past couple of decades or so. So without further ado, I will actually go and start with a little anecdote from my way to work the other day, where there is this paper that I picked up on my way to the office, and it says it has all of these typical headlines, city traders extinct, computers changing everything, so nothing unusual. If you look a bit more carefully at this piece of paper, you will see that there is something quite odd here. David Cameron, who was in charge when the Brexit was happening, is still there. You may wonder what the hell is he doing here. And then if you look more carefully, you will see that this was actually, this whole episode happened in 2006. So in 2006, IBM was saying, well, in 10 years, there will be no more traders anywhere. And I think we have a fair amount of time past that deadline, and traders are still there. So in this talk, I will try to put a little timeline covering my career and seeing how this technology and quant finance evolve in time and what would we expect potentially in the future. So I'll start with slightly introducing myself. So this is my first pass for my first work, my first job in an investment bank. I've been a quant, as you can see now, coming up to 22 years. I worked for a number of major investment banks, building mathematical models, running teams of quants, ranging from 5 to 40. That was building derivatives models. Also, I was doing some of the algo trading roles. And I'm also teaching as a visiting professor at Imperial College London in their Masters of Mathematical Finance program. Education-wise, I have a PhD in probability theory and Masters in optimal control from University of Waterloo in Canada. So what was it like at the very beginning? So let's see. So this is when I joined trading floors. They look pretty much, these two items you can find in abundance, probably like dozens and dozens of them. And if you look more closely, this is what the setup really was. So as a trader, you have these calculators to help you trade. And we have Excel and Bloomberg Terminal. That was pretty much it. Traders were not coding anything. They were not, that was deemed to be like really not fancy, On the quant side, you had like Excel and VBA. So Microsoft Excel was ruling the world back then. C and C++ were entering there. Typically, you even had some places that completely coded everything in C. And as a people who build models, there was lots of challenging things to do with analytic approximation. How do you make analytic approximations for various complicated derivatives? That was a bit of a dark art. Also, working from home was unfathomable. If you say to somebody, "I'm going to work from home," it's just unfathomable. You cannot even imagine what reaction that you would get. The main reference for all of these mathematics was this great book by John Hull. I think this was the third edition. This was the one that I was using back in the day when I started. And now it's in the 11th or 10th edition. It was sent in billions of copies. And there are lots of articles in rich magazines that help you build these complicated models. Now, this was all about actually computing in the end of the maths. So you would develop actually on your desktop. There was not much compute power you can get. But also, these models were then translated into some major banks' booking system. And these are in-house coded applications, and sometimes even Excel. Microsoft Excel was used for booking, which today would fail any audit at any level. And then what happened then? It's quite interesting, actually. There was a big revolution, and that came with Nobel Prize in 1997. That was awarded to Myron Scholes and Robert Merton for their famous Black-Scholes formula. Fisher Black, unfortunately, had passed away in 1995. Posthumously, this wasn't awarded Nobel Prize in economics, so he was left out. But that framework that they developed actually attracted a huge number of really avant-garde or the top of the crops in terms of probability theory. So you have, for example, many top probabilities moving into the field. For example, Albert Sharayev, who was a student of Kolmogorov, was there. Mark Orr, Canadian Robert Elliott, Chris Rogers from UK, and they really built absolutely amazing theoretical framework that led, for example, to a book that you can see here. This is the first edition, 1997, which really presented a very nice theoretical framework, which allows you rigorously to price rather exotic derivatives. And then the whole industry took off. There was the avalanche of products. And I was there basically in London in a desk of a bank. We were trading these, hedging them. It was quite exciting times. So if you look at the quant skill set shift, stochastic calculus became a must. You were able to build these cross-asset consistent models, and then Monte Carlo simulations and partial differential equations just showed up out of, they dominated this analytical approximation. C++ became the king. You then all have a migration of the technology from software engineering, from design patterns, also domain-specific languages came into finance as such. Python showed up, and the first time I saw Python was 2005. It looked like ugly. I was thinking to myself, this is even worse than VBA. It was really, it had a binding with C++, which made it quite attractive. Then what happened? There was a whole a line of shops offering to outsource the quant work. So they would try to build the models for the banks. And they're still around, some of them, but that never really took off completely in the sense of replacing the quants, because after all, and this is one of the takeaway, that quantitative work has become a core business for investment banks, and you would never outsource your core business. So that never was a viable proposition to completely replace this. And obviously, there are a number of industrial booking systems built in there. Another takeaway is there was a huge now push to get speed in computation, because you have complicated products, you have complicated models, you have many of them, and that gave rise to different ways to parallelize computing. And then after boom, there comes a bust. So thinking about this, 2008, which was much more of an event than 2020 COVID. Being there here on the right hand side, you have one of the investable indices. Actually, people were putting money into this. If you look prior to 2008 or 2006, this thing was returning you 40% per annum. So it's almost like Gazda Yezda index until it didn't perform anymore. I wasn't in this region when this Gazda Yezda was happening, but I was kind of aware what was going on, and this exactly was that. And interestingly enough, it actually took so many people by surprise, and then people basically paused back, trying to think how on earth this could have happened, and how on earth it so happened that some of the major investment banks just went bankrupt. And in this absolutely amazing book, late Mark Davis, it's really summarized it perfectly well, because he was saying, well, you know what, there are absolutely new questions that are opening up. And this is, by the way, the arbitrage theory and everything stays, but implications of how the market actually behaves, how it's interacting, needs to be readdressed. This chimes in with famous Eugene Fama quote in Forbes, even before the crisis, that people actually they realized that traditional statistics really doesn't predict the nonlinearity and variability of the markets very well. Traditional statistics gives you very tractable models, but this is probably not adequate for something as fast changing as nonlinear as financial markets, which are also very influenced by behavioral side of humans who actually do trade. So basically, post 2008, there was lots of thinking and lots of revisiting the principles, and what were actually the some of the fallouts or takeaways from there. So if you think about predictive models, you really need to go out of your comfort zone that maybe a statistician or probabilist, classical probabilists would do, and think about what really happens, because these time series are non-stationary, they are non-Markovian. They have many stylized facts, something which is not easily built into models. Little things, many little things. You must probably abandon this concept. Let's assume that assets follow some dynamics, and you write it out. That was typical first sentence in many of these papers before, because it doesn't follow anything that you can write. It maybe does follow on some small time scale or some isolation or some long term, but actually learning from data probably was the key takeaway of financial crisis. If anything, basically some of the biggest problems were the models were taken out of their applicability domain into the area of credit risk, where the data was really scarce. So something that worked for equities or rates, where the data was much more in abundance, was stretched into credit, where you have defaults every now and then, and you actually end up having to calibrate models on very thin data, disregarding the data completely. And if I would like to, if you want to say what is this that is different in machine learning, and you can find a lot more in quite a few books, including the one written by Paul Bilokon and Igor Haperian that just came last year. But this, in De Prado's Machine Learning for Asset Management, he basically says machine learning helps develop new theories. And what does it really mean is that you don't postulate anything. You go through the process of discovering the features, feature engineering, discover what actually drives. You also go from specifying model a priori to and testing it through statistical tests, R squared, p-values, f-tests, through actually cross-validation, so training and testing. So it's completely different paradigm. You train, validate, and then cross-validate to make sure that your model actually performs. And in that sense, you are much more robust in the way you take the data, and you really take the data as the data are. And also, the vast amounts of unstructured data can be taken in. And if data is scarce, you can have a ways to bootstrap to generate new data, which may not necessarily be new for machine learning, but definitely is something which is has become really coming to prominence. Another thing is about thinking about risk, and I cannot stress it more that the models that were predominantly based on volatility, using Markowitz portfolio, etc., that led into the crisis. Basically, people realize the volatility as such is not a great risk measure, because it doesn't take into account of jumps. Volatility is some long-term average, but if you basically want to account for sharp drops in the assets, you need to go with some other metrics, like some drawdown metrics in particular. And the VAR measure that was before in the markets was, for that reason, because it was not surgical enough, were superseded by this expected shortfall. And the whole framework of extreme value theory, which existed for decades before, was put into banking for very good cause. One more interesting side note here, one of the key elements of this extreme value theory is also one of the key mathematical foundations was regular variation theory, which was founded by Serbian mathematician Jovan Karmata in the early 30s and mid 30s, which actually stayed dormant. Karmata wasn't apparently even a fond or really new probability to any significant extent, but the depth of his theories were so profound that they were kept being rediscovered in a number of places. And then their usefulness, this is like one of these really key pieces of the universe that keeps finding its applications where you least expect them. But again, the looking at the risk became critical. And one takeaway as well, computational power is absolutely essential, but it's necessary, but not sufficient for finance, because you can have a perfectly quick tool to put in the wrong model to blow your heads off in no time. And so that's this. And then So what is going on in 2021? Again, academia, there's a number of journals. There are probably hundreds and hundreds of books. Mathematical finance, they're very similar to each other. There is, unfortunately, a bit too much of theoretical work which is not applicable, but maybe this is just my own personal observation. Mathematical finance is after all finance, and this is rather a concrete subject. Machine learning gone beyond prototypes, and this what I mean, they are really used to make money. And this goes beyond some internal bank system. For example, if you go to my LinkedIn, there was a product that we did recently using reinforcement learning to enhance some systematic volatility strategies that is actually traded by another financial counterpart. So obviously somebody else is willing to put their own money into this, believing it works. And what is not working is saying to machine, build me up a strategy. You really need to put lots of effort to actually isolate what is economical and trading framework that actually kind of makes sense, and where to surgically insert machine learning to help improve existing strategies that work okay. So that would be approach, rather than taking, throwing some data into black box and say, make money for me. You're not there yet. Shifting quant skill set. Yes, stochastic calculus is still there, but machine learning is absolutely getting essential. There are some other things that came up out of this quant work, this joint automatic differentiation for fast Greeks. In software engineering, Python took over to car, and everything else in actual day-to-day, if you look at the banking, that's probably where we are now. For good or not good, that's a different topic. And also, we have a still remarkable amount of C++ sticking out there. But there are other newcomers, like Julia, Rust, they all have their own edges. Now, there is also a layer of languages that I kept seeing in my work to varying degree for various reasons. And, VB is still hanging out there. Compute infrastructure, this is getting quite interesting because the cloud computing finally got through lots of banks' internal approvals. Because transferring the data outside of the bank became a bit sticky as a point. But not all banks have a cloud infrastructure. They prefer sometimes have their own servers. Graphical processing units are actually used in anger in production. It took, for this technology to actually be mainstream in some places, it took 5+ years, even 7 or whatever. But they are there, and they do offer a good advantage. I will also mention quantum computing, which was mentioned in some of the talks before. We teach it even in this Master of Finance at Imperial as a course. Even so, in 1-year program, you have that. I would keep an eye on it. Would I bet my house that if you go to place in a couple of years' time, there will be lots of quantum computing? I'm not sure. There's lots of. It's like a moving Titanic. You really need to think about these infrastructures and these frameworks as a business proposition. So there's lots of legacy. There's lots of ways to transition from one technology to other, which are not smooth. Even on GPU scale, it shouldn't have been that difficult. It took quite some time. So some benefits for machine learning also are creeping into the classical derivatives pricing. For example, there's this great project by Google in TensorFlow, where for quant finance, where you can use a graph methodology that exists in TensorFlow to effectively build your model library like that. And this is basically, you don't have to rediscover the wheel as we did some 10 years ago, building these graphs and whatnot. It's actually you're standing on the shoulders of giant being Google. And there is a deep neural network applications where you actually build replica of the models that are super fast. And this is done by RiskFuel, a Canadian company where I serve also as a non-exec director. I know how they're working. It's quite a cool application. So finally, some closing thoughts. You have a quote of Ray Dalio, one of the biggest investor of our times. He's been around for a while. He's traditional investor, and this is his view. So this is also taking it quite to the next level, I guess. So given that everything is free, what does it take? Only sky is the limit, but what do you have to have? And I will answer that, but first with another question. So if we look at this is middle-aged, 5'6", which is under 170 guy. not particularly in good shape, never played basketball. What does it take for him to have a major impact on the game of basketball? What does it take for this guy? Can he ever have an impact? And the answer is, it's a vision. Oops. Sorry. So this guy has to have. Oh, sorry, this is not some reason working properly. Yeah, he has to have a vision. So the answer to my question is that. So you need to have a vision to. Apologies for this. So let's keep it there. So you need to have a vision to basically see. I have Michael Jordan. I have a Scottie Pippen put in place. I have a bunch of players, Kukoc, for example, as well, as we know, and obviously the coach. So on that note, I will wrap up there and open up for some questions.
Hi, I'm back. Thank you very much, Vladimir. How are you feeling? Are you good?
All good.
I'm just looking right now. One of the questions is I would like to ask you about the first kind of slide where you mentioned IBM saying that traders are going to be extinct in 10 years' time. Obviously, that's incorrect, but with the rise of these trading online platforms that make it easy for everyday people to kind of access and see what's going on, do you think that might be true in some future time?
I think it is a probably broader question, and if it happens, the machines will replace humans in many other places as well, including even probably medicine or whatnot. So I know if you are worried about computers replacing humans in trading fully, at that point we will be much more worried about them replacing us in everywhere. I think that the problem with trading is, or what is peculiar about trading is that it is the whole area is basically influencing itself. So it evolves very quickly because of itself. If you look at some statistics of the time series and data that's there, it's quite different from even what 5 years ago was the case. Whereas, if you look at other applications of AI, some facial recognition or some pattern recognition in sports, these moves were pretty much not that dissimilar over the last number of years. They do evolve at much smaller scale. So I think the finance is probably the most challenging, and there's also behavioral aspect of it still. So my answer to that, it's almost philosophical questions whether computers completely going to replace us at the major of what we are doing.
Okay, I understand. Thank you very much for this talk. This was the first talk in kind of our trading block on this stream. We have two other speakers coming up talking about different aspects of the same trading topic. So thank you very much, Vladimir. I will see you later.
Yeah, thanks.
Okay, so that was Vladimir from Imperial University, London. I mean Imperial College of London. Next up, we have Irina Tserovina from Pricewater Company. She will be joining us at 11, so stay tuned. We'll be back in 5.